All right, so even when expressions get more complicated, we still have to treat them by working with only one side. You can't treat them as if they're equations. You can't add, subtract from both sides or work with each side separately. You have to work with just one side until it looks like the other side. So in this expression here, you've got a typo in yours, and I'm sorry about that. What it should read is secant x plus 1 minus 2 secant x plus 1. All right, so what I see here is a common factor, so I'm going to start by factoring. So I'm going to take out secant x plus 1, and then I'll have a binomial left here, so secant x plus 1 times secant x plus 1, and then secant x plus 1 times negative 2. All right, I can, ooh, where'd my plus 1 go? I can simplify this right expression. So secant x plus 1, this is going to become secant x plus 1 minus 2 is minus 1. I know this is a difference of squares. I'm going to end up with secant squared x minus 1. Of course, secant squared is 1 over cos squared. And actually, at this point, we know that this is equal to tan x. It's one of our known identities. So we could continue on to prove it. But at this point, you could say equals tan squared, x equals right-hand side. Or you could go on to prove it, but you don't need to. If you were to go on to prove it, you would make a common denominator. So let me just do that here. So minus cos squared over cos squared. That's going to give you 1 minus cos squared over cos squared. And of course, this is Pythagorean identity, so that's sine squared over cos squared, which is again just tan squared, which is also the right-hand side. So if you recognize this identity, you can use it. If not, you can go on to prove it.